So to find out where the function is increasing or decreasing, well, increasing means that the slope of the tangent lines are going to be positive. Decreasing, the slope of the tangent lines is going to be negative. So that's first derivative information. And then once we know that, we can find out where there's minimums and maximums. Then use the second derivative to find out if it's concave up or concave down. So for the derivative of natural log is going to start out with 1 divided by the argument. And then the chain rule says take the derivative of the argument. And then there's two things to look for. Where's the function undefined? So division by 0. Well, since this is an even power and this is a positive number, then only complex numbers are going to be roots of that. So as far as real numbers, we don't have to worry about it. But we do need to find out where does the derivative equal 0. And luckily for us, the only way a fraction can equal 0 is if the numerator equals 0. And since we're dealing with only real numbers, no complex roots, then x equals 0 is the only place. So I'd like to verify that on the calculator. So the original function was the natural log of x is raised to the 4th plus an 8 seems to be a very well behaved function. X equals 0, there's a minimum. So there's a minimum at 0 and 2.079. And it looks like the derivative is negative on that side and positive on that side. Well, I could go back and take a look at this. Again, the denominator having an even root and a positive number, this can only be positive. Then the only way that this can be negative is if x is negative. So that means that the derivative is negative, or in other words, it's decreasing to the left of 0, and it's increasing on the right-hand side. So we're nearly more than halfway done. So decreasing from negative infinity to 0, but not including 0. So decreasing on the left side and increasing on the right side from 0, but not including 0, then all the way to positive infinity and beyond. Next, where is it concave up and concave down? So for that, we need the second derivative. This is going to be a little more challenging because we need to use the quotient rule. And by challenging, I mean fun. So the denominator is squared. Then take the derivative of the numerator. Leave the denominator alone. Minus, take the derivative of the denominator and leave the numerator alone. And once again, we need to know, where is it undefined? Nowhere. Where is it equal to 0? Only where the numerator equals 0. So let's see, this is going to be 12x to the 6th when I distribute. This is negative 16x to the 6th, so that's negative 4x's to the 6th. And then distribute this with the 8 is a 96. So plus 96x squared. And then factor. So let's see, I could factor out of 4, and that would leave 24. So I'd leave negative x to the 4th and 24. There we go. And so we're going to get, from this, we could either get all real numbers or some combination of real and imaginary. Let's see. Well, it's factored, set each factor equal to 0, so we'd have 4x squared equals 0. And then this would be x to the 4th equals 24. Once you set it equal to 0 and move the negative x to the 4th over. So this is simply x equals 0. And then this, we'll take the 4th root and we would get plus or minus the 4th root of 24. That's not something I would just take a look at the graph and say, obviously, the 4th root of 24. So let's see, trace in the 4th root, I could do like this, except I need to put the 4 first. 4th root of 24. So right here is where it's changing. So this seems to be concave up, and this seems to be concave down, or cupped down. Now I also got x equals 0, which is a place where it might change from concave up to concave down, but in here it doesn't really look like it. So what I'm going to do is test it, because the graph cannot always be counted on. So I'm going to test it. Over here is, well, in the middle is 0. Over here is negative. So the x value for the 4th root of 24, 2.213, and here positive 2.213. And then we're going to test it in the second derivative. So keep in mind this was the numerator. So we've got the second derivative is equal to, so this was the numerator once we simplified it, 4x to the 6th plus 96x squared divided by So in a way with this one, I don't really need to check to see what happens with the denominator because it's going to be positive no matter what. Really, I just need to find out the numerator. Is it positive or negative or what's going on? So we found out the second derivative equals 0 here, and equals 0 here, and equals 0 here. But what about the regions in between? So we could test, for example, over here, -3, and see is the answer positive or negative. So it's going to be -4, and then a -3 is raised to the 6th, plus a 96, and a -3 squared is 9. So that would be a -2052 divided by a positive number, so that's negative. So it's negative all over here, which means that it's concave down, so it should be curved something like this for concave down. And that's on the far left-hand side. So this, yep, that looks concave down over here on the left. And then what about in this region? So we'd have something like test x equals -1. So I can even go back and change this to a -1, and then a 1 squared, and then it's positive. So positive means that it's concave up, something like this in that region. So go back to the graph, and so it's saying in that region, in there, it should be concave up, which looks correct. And I think the same thing is going to happen over here, like if I test a 1. So this would be a +1. That would be a +1 squared, and it's positive as well. And so this would be concave up. And then finally over here at, let's say, 3. So this, change it to a 3 raised to the 6, and this is a 3 squared, so 9. Negative again. So the graph was actually reliable. So we've got, let's see, concave down over here on the left. So from negative infinity to negative 2.213. Also over here on the right, so 2.213 off to infinity. And for concave up, well, that's all of this. Although technically we got a derivative equal to 0 there, which is neither concave up or concave down. So we have to write these separately and throw out the 0. So just as it is in here, so from negative 2.213 to 0, but don't include the 0. And there's everything increasing, decreasing. We found a minimum and concave up and concave down.